Hi, welcome to Space Time with Robert. I'm Robert, and today we're going to be setting up the Explore Scientific 10-inch Dobsonian, and I'm going to just show you whatever I can while we set it up. This is where I keep the base. You might notice that it's all glued together, and that's because, well, these fastening screws, they're just not up to the metal of public outreach. It's a little decorated. All right. Cool thing about telescopes is they have one thing in common so far with Batman, and that's the Lazy Susan. You know, Batman has his car on it, whatever. All right. Next up, this is the actual tube itself. I just keep it in the back seat, and I like to keep it on a towel. The reason I do that is because I have some lubricant on the altitude bearings, and that I don't want getting on the back seat. But, all right, now I'm gonna pull it out. One of the things I really gotta mention is just make sure that you love yourself, you carry yourself. Don't just yank it out. Don't twist and lift with a jerking motion. You are far more important than any telescope, so don't forget that. All right. Next, as I pull it out, I'm gonna try and not snag it on anything. There's a little telescope actually on the very front end. I wanna make sure that I don't hit it on anything. I'll show you what that's all about. So these are the altitude bearings, and I've already tightened everything so that it doesn't slide, hopefully. All right, lift with a smooth, steady motion. Okay. And that's it. It's set up. It's all done. It's ready to go. Not really. We're gonna have to align everything and make sure it all works. So let's do that. This is how I get the dust cap off, is it's really tight in there and I can't just yank it off by its handle here. So I gotta use a key or a guitar pick or something to leverage it out. And you just gotta, there it is, ta-da! Okay, you look right down into the telescope. Do you see the mirror?
Wow, yeah.
It's a big old mirror. So that's what makes this telescope so affordable, is it's not using a big hunk of glass like that's up at the front right here in this little telescope. So if we used a big chunk of glass, I think it has to be precise within one out of a million or something like that of an inch or something. It's got to be extremely precise glass for it to be usable for astronomy. So a big old mirror though is way more cheaper to make, and if you look in there, it's like a big makeup mirror, right? Yeah. So cool. If you want to come over here real quick, and have you had a look down into the actual telescope itself yet? Because you might see yourself actually. Who knows? This is how Newtonian telescopes work. So Isaac Newton is the one who's credited for this. Let's see what he did. If you look right here, you can actually see a secondary mirror, this little chunk of glass in there, and that's his contribution to this whole design. Other people already thought that, hey, you could use mirrors to check out space, but he was like, white light contains all the colors, and these astronomers are complaining about colors showing up in their telescopes. What if we just used a mirror and then used a secondary mirror on the inside to bounce all the light out of a hole that's right here? And so this is the focuser, and this is what we'll be looking through so that we don't have to sit inside the telescope and check out what's going on over there. This is the telescope focuser, and it's a hex focuser is what they call it. It's got this hex design, and it's like 3 inches in diameter right here. I don't know what the purpose is of that specifically, other than it's really sturdy and awesome. This, you can tighten it, and that will actually lock the focuser. It will just make it tighter so it doesn't actually move. And I don't really use that often, just because I'm always focusing this thing. So I just keep it loose. But that's something you can do if you ever want to do that. This is where we're going to be putting the eyepiece. You can actually look in here itself, and you'll see the primary mirror as well as a little aiming reticle and all that stuff. By the way, I totally forgot to mention, these scaffoldings, they call it the spider arms. I've never seen a spider with arms. I would never want to see a spider with arms. And but these 4 points are usually why you have 4 points showing up on Newtonian photographs of stars. The stars with the 4 points that are coming off, like the Christmas stars, they're usually photographs that have been taken with telescopes a lot like this. And so I just wanted to point that out. Mystery solved, right? All right, so back over here to the focuser. What's really cool about this is this one screw actually tightens a clamp on the inside. So it's not like I'm screwing in a screw to tighten an eyepiece down in there. So you're not gonna scratch up your eyepiece too much. And then these screws, you can remove this whole entire adapter and now fit an even bigger eyepiece in there. So a 2-inch eyepiece, which we have. And I'll show you how to do that once I get it all set up. And I'm gonna tighten it like this, and that just tightens the clamp. It doesn't actually screw into the whole thing. All right, so collimation, let's do it. This is the Meade collimator, and it's going to the Explorations Academy. I don't think I mentioned that this telescope's being, it's getting donated to one of the local schools around here, so we want to give them everything they need. This is one of those things. This is a collimator. It has an aiming reticle or a target right here, and so the idea is that if I shoot a laser out here and it goes into the telescope, then it should hit the back mirror and then go right back to the secondary mirror and then come right back out the eyepiece, right back where the laser was coming from. All right, here we go. Let's collimate this thing. And that's a big word, collimation. Nucleosynthesis. Okay. Get that on there. Okay, so that's not perfectly tight. So this tube right here is actually an extension tube. You can unscrew the entire thing off and it will comes off of its threads, and you're going to want to remove all of that if you want to have enough focal length for a DSLR camera. Otherwise, this is how it's set up for viewing purposes. So I'm going to turn on the laser. Cool, now I have a much brighter laser. Let's see what it looks like. So that red dot needs to be perfectly on the circle, or in the circle, or as best as you can. And since it's a mirror, we're going to be using reverse steering. So this one should make it go that. Let's just mess with it. All right, thumb screws. Look, Mom, no tools. You can actually just tweak these. Going down, going back. Oh, look at that. Oh, almost. I had it. Ooh, how about that? That looks good. All right. So now that the laser's hitting that spot, it should be hitting the secondary mirror and then coming out and hitting the exact same spot. Let's see. So if you look back here, it's not. So that means the primary mirror is off. We got the secondary mirror to be aligned, but now we need to align the primary. What we're going to do now is we're going to loosen up these screws, these little ones, and this is kind of like tuning a guitar. So the tuning knobs on a guitar will keep the guitar in tune, right? And so we're going to loosen these up, so now we can start to tune this mirror and line it up with that dot at the end there. Okay, so I'm going to be looking at that dot while I mess with each one of these, just like I did with the secondary mirror. Let's see if I can not mess it up, because I have tightened these a little too much before. Okay. And now that that dot's starting to disappear, that means it's going right back to where it came from, which is what we want. Perfect, we're done. I know that was exhausting, right? No, we're not done. You need to actually tighten the screws up, otherwise the mirror is just gonna loosen itself back up again and not be in alignment. Perfect. All right, so now that the mirrors are all nice and pointing at each other, we have a hall of mirrors going on in there. We can turn this off so I don't waste that battery too. Take that out. And now the fun part. Let's see what the telescope sees. This is a 32 millimeter, and scratched to hell. It's been through battle. Have I even mentioned what this telescope's name is yet? No? Okay, now's probably a good time to introduce you. This is John II, named after John Dobson, and I believe the Dobsonian mandate was to show at least 1,000 people space through a telescope, if you own one. We've only achieved about 500 signatures. Each signature is somebody who has looked through the telescope, and if you want to be a part of this, you can come and hang out with me at Taylor Dock, Sundays at sunsets, and I'll show you as much space as possible and get your signature on here as well. Welcome. All right, so here's the eyepiece again. Now the next objective is to get this guy to, this whole telescope, to be pointing at the same thing that this little telescope is pointing at. So, I'm gonna remove the dust caps. This viewfinder is a 8 by 50 millimeter right angle finder. That means that it's coming out at a right angle, and it's also a correct vision, or a correct image. So that means when I look through here, nothing's going to be reversed or flipped upside down. It's going to be just like looking through a better version of your eye, I guess. So I'm going to aim it at something. I see a red sign on a building really far away, and I'm going to turn the telescope over to that direction. You shouldn't look at people's houses. If you can, just avoid it. It's definitely an invasion of privacy. Just check out stars. And it's not gonna be that interesting anyways. You're gonna be looking at what they're watching on TV upside down, and it's just weird to do. But, all right, now, so don't look at the sun and don't creep on people, please. Next up is, it's the Herald sign of the building, Herald. It's a really iconic building here in Bellingham. And when I look into this eyepiece, I can see the Herald building. I could see the American flag floating next to it in a radar dish. And when I look in here, I see the Herald building, but the crosshairs are off. Let's see if we can actually show you what it looks like with a camera. All right. So this is the viewfinder. That's the Herald building, that red sign there, that's just a little bit off to the crosshair. When I come back away from that, and go over to the eyepiece, oh, there's that building, or that's that sign, the Herald, right? It's upside down, just like I said. So now what I want to do is I want to get this to aim directly at what that was aiming at. How I'm going to do that is these screws here can all realign how this is pointing. This is actually a spring that just holds it in place. So I don't think that this, no, that doesn't do anything. It's just these two screws. All you do is mess with these two screws, and that went too high. Now I'm going left and right. Booyah, perfect, done. So if you look at my phone, if you can, that's aiming right on the red little Herald sign. That's a person. And then there it is. Kind of. Oh. But you get the idea. All right. Next up, it's ready to go. You can start looking at space right now. So this is the next thing we were going to give the Explorations Academy, was the Hyperion modular eyepiece, 10 millimeter. It's a beast. It's beautiful. It's modular, so that means you can unscrew this part and it becomes a 2-inch eyepiece. And then you can put that back on and it becomes a 1-inch or 1 1/4 inch eyepiece. These things are so cool. And so that way they have all the viewing power they need. Look at that thing, that's a beast. So, oh wow, that Herald building. Yeah, that's definitely out there now. That's the H on the Herald. I wonder if we can get like a bird or something. But yeah, that eyepiece zooms in really close. It's very powerful, and you'll definitely see the rings of Saturn, moons of Jupiter, all that stuff, even storms on Jupiter's surface. And if that isn't enough for you, here is a Barlow lens. We'll give this to you as well. So what this does is this doubles the magnification of your eyepiece. So if I were to remove this one, let's say I put in this 32 millimeter again, right? Now I'm going to extend the 32 millimeter with a Barlow. And this is a really good setup for kids with glasses, because what it's going to do is allow them to get a little bit further away from the telescope or the eyepiece without bumping their eyeglasses into the eyepiece itself. They'll be able to achieve a focal point further away from the eyepiece. And so keep that in mind for students with glasses, or if you have glasses. So let's see what it looks like. So now I'm farther away from the eyepiece. I got more eye relief, and I'm more zoomed in. So it's just a little trickier to keep your eye right over the spot, but yeah, it's pretty cool. I mean, there's so many things you could do. Here are filters. Filters are useful, especially for this kind of a telescope. It's so bright. It's going to let in so much light from the moon that when you look away, you're going to have a very strong after image in your eye. That means you're still going to see the moon even when you're not looking at the moon. And it's a little disorientating, and to alleviate that, I'm going to give you a moon filter. Yeah. I'll make sure I give you the nice one. This is the Mead one. And so all eyepieces typically have threads right here in the nose piece, and so you can screw in a filter. That should make everything really dark. Oh yeah, it looks like nighttime now. However, my phone is still brightening up the image, but you can see it's a little bit more gray. And that's what it'll do for the moon, is it's just going to make it dimmer so that it doesn't hurt your eye as much. Oh, those birds, that's so cool. But yeah, I really recommend using the moon filter if you're going to be looking at that. Also, it helps for Venus too, so you can see the crescent of Venus because it just gets so bright. One thing I actually forgot to mention really quick was, two things, is how to balance it. So, as I was mentioning before, I do tighten everything before I pack it up. Let's see, is this run into the base? Let's see. Okay, no it doesn't. So that's the goal there, is to make sure that that's nice and flush, and you're not going to want that running into the base, otherwise you can't look directly above you. However, I'm going to move this up a little bit so I can show you over here. These screws, once I start loosening these are going to loosen the entire telescope, and it can now slide in between these two brackets. So usually I do this while it's not on the base. I'll do it while it's standing over there or something like that. But if you have to do it in a hurry because you've just attached some new equipment, you've attached a heavy camera now at the front, and all of a sudden your telescope is slipping forward and you can't stop it from doing that, you loosen up those things, and now you can just gently slide it in between the brackets, just like that. And you're going to want to do that too if you put this on a different mount. You can actually remove these just by unscrewing these parts, and then put in a dovetail plate right there and mount this completely on a different mount, which is really cool. I love that about this telescope, is it's versatile. You can put it on different mounts. That's not something that you could typically do with other 10-inch Dobsonians. But that's all I wanted to show you real quick, was just that you can readjust the weight distribution pretty easily. Now I'm just going to tighten those back up, and that's it. Thanks. All right, wrap up time. It's getting cold out. You want to go home. No one's looking through the telescope anymore. Let's get it packed up. First rule that I usually go by is one thing at a time. If you start handling a bunch of stuff, you might drop something and it'll roll away. It's a disaster. So let's just do it all one at a time. Here's a dust cap. Goes there. Here's another dust cap. That dust cap goes here. Then this big dust cap. If you notice, dust caps are the first thing I usually do. I don't like dust. So now that the dust caps are on, what's next? Let's do the eyepiece. The eyepiece has a filter, so I'm going to remove the filter. If you have one, I really recommend using it. If you don't, I recommend getting one. It's a collapsible dolly, and it fit great in your car. You can put it on put a telescope on it. So I usually just grab the altitude bearings and push it away, and once it's there, block it with my foot. So it's a little finicky, but it works. Thanks for checking out the instructional video on John II, the 10-inch Dobsonian Explore Scientific Telescope. I know these things have the hugest names. That's why we named them. If you want to come check out these telescopes or see what images they take, you can look us up on Spacetime with Robert on Facebook or Instagram, or come check us out at the docks down at Taylor Docks Sundays at sunsets. We're out there with the telescopes, and we love to show people space. Come out and bring your friends. We'll let you sign them as well, and hopefully you'll see a telescope in your school soon that has been covered in signatures. Thanks, and have a great night.